Let us go with the equation of deformation. Why? Because like I said, when a part is subjected to two equal and opposite push forces or two equal and opposite pull forces, then a certain amount of deformation is going to take place inside the body. Then we need to find out what is the equation for deformation. In the previous slides, we have discussed modulus of elasticity E is stress sigma upon strain epsilon. We have also discussed in first few slides that stress is force upon area and linear strain is delta L upon L. Hooke's law or modulus of elasticity states that stress upon strain, stress value, if I'm putting over here, and if I'll put the strain value, then I'll get P upon A divided by delta L upon L. If I properly arrange the values, then delta L is PL upon AE, where delta L is deformation or change in length, P is the force, tensile force, compressive force, whichever is applied, L is the length, A is the cross-sectional area, and E is the modulus of elasticity. There are many numericals which are asked on modulus of elasticity, deformation. So let us see one of the numerical on deformation, how to find out the deformation. A circular rod of diameter 20 mm. So there is a rod which is having diameter 20 mm and is 500 mm long. So its length is given, which is 500 mm. It is subjected to a tensile force. It is subjected to a pull force which is of 50 kilonewton. We always do the conversion of kilonewton to Newton. So I'll convert it into 50 into 10 raised to 3 Newton. If modulus of elasticity is 200 kilonewton per mm square, find stress, strain and elongation of the bar. So modulus of elasticity is given in 200 kilonewton per mm square. I'll have to do the conversion into 200 into 10 raised to 3 Newton per mm square. Let us find out stress, strain and elongation of the bar. Now first thing I need to find out is the area. Since diameter is given 20 mm, so area is going to be pi by 4 into 20 square. The next thing given is length, which is 500 mm. Modulus of elasticity is 200 into 10 raised to 3 Newton per mm square, and force is 50 into 10 raised to 3 Newton. Since force is given, area is given, so I can easily find out the stress. Stress is force upon area, which is 50 into 10 raised to 3 divided by pi by 4 into 20 square. If I'll do the proper calculations, the answer turns out to be 159.15 megapascal. 1 megapascal is 1 Newton per mm square. Next, I have to find out the strain. So I'll find out strain, which is epsilon. Now since modulus of elasticity is stress upon strain, so strain will be stress upon modulus of elasticity. So it is stress upon modulus of elasticity. I'll write down the value of stress that I have already calculated, which turns out to be 159.15, and modulus of elasticity is 200 into 10 raised to 3. If I'll do the proper calculations, the value turns out to be 7.96 into 10 raised to minus 4. Now, since I have found out the value of linear strain, the formula for linear strain is delta L upon L. I'll write down the value of linear strain, which is 7.96 into 10 raised to minus 4, is deformation upon length, which is 500. if I'll do the proper calculation, I'll find out the value for deformation or the elongation, and the value turns out to be 0.398 mm.